Let's talk about arithmetic sequences. First, let's recall the definition of a sequence. A sequence is a list of numbers that follow a pattern. We have an example of an arithmetic sequence here of -4, -1, 2, and 5. A sub 1 represents the first number in our sequence. A sub 2 represents the second number in our sequence. A sub 3 represents the third number in our sequence, and A sub 4 represents the fourth number in our sequence. Now, the list of numbers in an arithmetic sequence is found by something called the common difference. The common difference in an arithmetic sequence is the difference between two consecutive numbers in the sequence. So we want to find the common difference of our example of -4, -1, 2, and 5. Let's look at the first two numbers in our sequence and find the difference between them. So we write -1 minus -4 equals -1 plus 4 equals 3. Remember that when we have two negatives beside each other, the operation becomes positive. And so that's why we have -1 plus 4 equals 3. Now looking at the next two numbers, -1 and 2, we want to look at the difference between them. So we have 2 minus -1 equals 2 plus 1 equals 3. Now let's look at the next two numbers and find the difference between them. We write 5 minus 2 equals 3. So the common difference of this arithmetic sequence is 3. Now, how do we find the nth term of an arithmetic sequence? We do that by using this formula: a sub n equals a sub 1 plus n minus 1 times d. So in our sequence that starts with -4, -1, 2, and 5, we want to find the 47th term. So using our formula, we'll just substitute in the values that we're given. We want to find the 47th term, so we have a sub 47 is equal to -4, which is our first term, a sub 1, plus 47, which is the term we're looking for, minus 1 times 3, which is our common difference. This simplifies to -4 plus 46 times 3. And then we have -4 plus 138 equals 134. So the 47th term in this arithmetic sequence is 134. Now let's look at an example where we want to find the first term in the sequence. So we'll use the formula a sub n equals a sub 1 plus n minus 1 times d to find a sub 1. The information that we're given in this example is that a sub 19 equals 42, d, which is our common difference, is -2/3. So we'll substitute the information that we've been given to help us find the first term, a sub 1. So the 19th term is 42, a sub 1 is our unknown, 19 is our n, and d is -2/3. So on the right side of our formula, we have that 19 minus 1 is 18, then 18 times -2/3 simplifies to -12. So to get a sub 1 by itself, we want to add 12 to both sides of our equation. So here on our next line, we have 42 plus 12 equals a sub 1 plus -12 plus +12. Positive 12 and -12 will cancel out on the right side. And so 42 plus 12 is equal to 54, which is a sub 1, our first term. let's look at another example involving arithmetic sequences. We want to look at something called arithmetic means. Arithmetic means are terms between any two non-consecutive terms in the sequence. And we have an example of that here. Our first term is 4.9, our last term is 2.5, and we're missing a few terms in between our two non-consecutive numbers. And these missing numbers is what we call the arithmetic means. Our task in this example is to find those missing numbers. So the first step we should take is to find the common difference. And we'll use the formula a sub n equals a sub 1 plus n minus 1 times d to find our common difference. Using the information that we're given in this example, we'll substitute that information into our formula. So we'll take advantage of the fact that we know what a sub 7 is, which is 2.5, and that we know what a sub 1 is, which is 4.9. Substituting those numbers into the formula, we have 2.5 is equal to 4.9 plus 7 minus 1. 2.5 is the seventh number in the term. 7 represents our n, which is the seventh number, and d is the number we're looking for. And 4.9, of course, is our first term, a sub 1. So 7 minus 1 simplifies to 6. So we have 2.5 is equal to 4.9 plus 6d. Now to get 6d by itself, we have to subtract 4.9 from both sides of the equation, which I've done here. So we have 2.5 minus 4.9 is equal to 4.9 minus 4.9 plus 6d. 4.9 minus 4.9 cancel out, and so we're left with negative 2.4 equals 6d. Now to solve for d, we want to divide both sides by 6. So on this line here, we've divided both sides of the equation by 6. 6d divided by 6 will cause that 6 to be canceled out, and we're left with d on the right side. And then on the left side, we have minus 2.4 divided by 6. Negative 2.4 divided by 6 is equal to negative 0.4, which is equal to d, that we call our common difference. Now we're ready to find the missing terms in our sequence. So we need to find a sub 2, a sub 3, a sub 4, a sub 5, and a sub 6. So once again, we'll use our formula for the arithmetic sequences, which is a sub n equals a sub 1 plus n minus 1 times d. So to find the second term in our sequence, we write a sub 2 is equal to 4.9 plus 2, which is our n, 2 minus 1 times negative 0.4, and that equals 4.5. To find our third term, n is 3 again, so we have 4.9 plus 3 minus 1 times minus 0.4 is equal to 4.1. Our fourth term is 4.9 plus 4 minus 1 times negative 0.4, and that equals 3.7. Our fifth term is 4.9 plus 5 minus 1 times minus 0.4 equals 3.3. And the last term we're looking for is a sub 6. So we have a sub 6 equals 4.9 plus 6 minus 1 minus times minus 0.4 equals 2.9. So I'm going to fill in the missing terms of our sequence. 4.5, 4.1, 3.7, 3.3, and 2.9.